Ever stop to think about the physics behind something as simple as opening a door or twisting the cap off a bottle? It feels like second nature, right? But underneath, there's some really elegant science at play. So today, we're going to pull back the curtain on the forces that make the world turn.
Okay, let's start with a really simple question that you've probably seen a million times, but maybe never really thought about. Why are door handles always placed as far away from the hinges as possible? And I'll give you a hint, it's not about aesthetics, it is pure physics.
You've probably tried this as a kid, right? If you try to push a door open right next to the hinges, it is ridiculously hard. You have to put your whole body into it just to get it to move an inch. It honestly feels like you're fighting the door itself.
But then you move your hand out to the handle, give it a little push, and it just swings open effortlessly. Now, you're not pushing any harder, but your push is suddenly way more effective at making the door rotate. This kind of magical turning power is exactly what we're going to dive into.
This brings us right to our first major concept. The scientific answer to our little door handle mystery is a wonderful thing called torque.
So, in physics terms, torque is the measurement of how well a force can make something spin or rotate. The big takeaway here is really simple. It's not just about how hard you push, it's all about where you push. That's the secret sauce.
So, what are the key ingredients that make up torque? Well, it really boils down to three things. First, obviously, is the force you apply. More force, more turn. Second is the distance from the pivot point, that's your lever arm. And third, maybe surprisingly, is the angle you push at. Turns out, for the most bang for your buck, you want to push at a perfect 90-degree angle. And here's where we see it all come together in one simple, elegant formula. Torque, which we represent with the Greek letter tau, is just the distance r times the force F times the sine of the angle. This beautiful little equation perfectly explains our door. When you push on the handle, the distance r is huge, which means you need a lot less force F to get the exact same amount of torque.
Let's think about another real-world example. A wrench is just a torque machine. You've probably noticed that using a longer wrench makes it way easier to loosen a really stubborn nut, right? That's because you're increasing that distance r, which means you don't have to strain as much to get the job done.
You know what? Let's just crunch some numbers real quick to see exactly how this works. I promise, the math is super straightforward.
All right, let's say you apply a force of 20 newtons. To give you a feel for that, it's about the same force you'd need to hold up a 2-kilogram bag of sugar.
And you apply that force about half a meter away from the pivot point, and let's say you're pushing at that perfect 90-degree angle we talked about.
So what do we get? We just multiply them. 20 newtons times 0.5 meters gives us a torque of 10 newton meters. See? Simple as that.
Okay, but here's where things get a little more interesting. When you apply a single force to create torque, you don't just get a spin, you also get a little bit of a sideways push. So what if you wanted a pure spin, with absolutely no sideways motion? Well, for that, you need something else entirely. You need what's called a couple.
And this right here is the fundamental difference. A single force creating torque will always give you some linear motion, a push. But a couple is special. It's designed to give you pure rotation, and nothing else.
So what exactly is a couple? Well, it's pretty much what it sounds like, a pair of forces. But they're a very specific pair. They are equal in strength, but they are acting in completely opposite directions. The result is a perfect turning effect with zero push or pull.
And this is what makes a couple so cool. Because those two forces are equal and opposite, they completely cancel each other out in terms of straight line motion. The net force is zero, so all you're left with is this beautiful, clean, unadulterated spin.
And the wild part is, you actually create couples all the time in your everyday life, probably without ever even thinking about it.
I mean, just think about turning a steering wheel. Your left hand pushes up while your right hand pulls down. That's it. That's a couple in action. It's that perfectly choreographed dance of two equal and opposite forces that gives you a smooth, controlled turn.
Or how about opening a jar or tightening a bottle cap? It's the exact same principle. Your thumb pushes one way on the cap, and your index finger pushes the other. That balanced set of forces is a couple, and it makes sure the cap just spins in place instead of flying off to the side.
Okay, so let's wrap all this up and make sure it really sticks. It's time to put these two concepts, torque and couple, head-to-head for the final showdown.
So here's the bottom line. Torque involves one force. That means the net force isn't zero, so you get both a turn and a push. A couple, on the other hand, uses two balanced forces. The net force is zero, which means you get a pure, clean spin. It really just comes down to whether you want to just turn something or if you want to turn it and push it at the same time.
And there you have it, the simple but powerful difference between torque and a couple. The next time you open a door, use a wrench, or turn a steering wheel, you'll know exactly what's going on with the physics. So I'll leave you with a question. Now that you know what to look for, where else do you see these incredible forces at work in your daily life?